Alright, and the solution for this week's quiz quest post is basically, let's have a look. So, the table gives information about the first 6 terms of a sequence of numbers. Term, number, term of sequence. Prove algebraically the sum of any consecutive numbers in this sequence. Okay, so the first thing we're going to do is we're going to find a pattern between the term number, okay, and we're going to find a pattern between the term of sequence. So already when you look at the numerical version provided above, we can see that there is a pattern, right? So when it is 1, it is 1 into 2, which in other words I can write as 1 plus 1 over 2. And then this is 2 into, in other words I can write this as 2 plus 1 over 2. And same way I can write this as 3 into 3 plus 1 over 2. So there's a pattern. And using that pattern, I want to generalize this for any variable. And that is why I'm going to introduce n as my term number. And if I introduce n as the term number, then if we compare the same pattern we have above, this should then be n times n plus 1 over 2. And we can of course check whether this works for our cases above. So when it is 1, we have 1 times 1 plus 1, which is 2 over 2. Or when it is 2, we have 2 times 2 plus 1, which is 3 over 2. So this basically works for all the cases. So this is our general formula that we are going to progress with. So what do we notice? They are talking about sum of any 2 consecutive terms. Now I have written basically that one term of this sequence is n, and I'm going to remove the multiplication sign and write it as a normal multiplication for algebraic purposes. So the other term, that is the next term in this line, if I was to write the next term, would be n plus 1, right? N plus 1 is the next term of the sequence. Now that would be n plus 1 into n plus 1 plus 1 all over 2. And I can simplify that as n plus 1 into n plus 2 over 2. And we are looking at the sum of these two sequences, that is the addition of these two. Now if I want to simplify this addition and see if I'm going to get anything to do with square numbers, then the next thing I have to do is basically add these two terms together, right? And when I'm adding, the denominator is already common. So this is n into n plus 1 plus n plus 1 into n plus 2 over 2. And then we can take out a common n plus 1 here. So n plus 1 open bracket is n plus 2. That over 2. And this then simplifies into n plus 1 plus 2n plus 2 over 2. And this again simplifies as n plus 1 into, I'm going to factorize the 2 out here. So this is 2n plus 1 over 2. The 2's are going to cancel, leaving me with n plus 1 squared. So basically, it is a square number, right? We needed to show that it is going to result in a square number, and it did. Now, why is it a square number? So we have the power 2 there. So what is the term for which we are looking at? N plus 1 is the square term, right? So n plus 1 into n plus 1. That is the square number. So therefore, we have proved that this statement is true.